Hello students, today we are going to discuss about sequential circuits. Before discussing about sequential circuits, we have to know about combinational circuit. Basically in combinational circuit, output depends only on current input and it is able to perform some useful operations like add, subtract, multiply. As it depends only on current input, it has no memory element and no feedback. While in logic, output depends not only on current input but also on the past values. As it has past values, so it requires some memory for storage. So sequential circuits have some type of memory to remember the past input values and also has feedback to give those past input values as a current input to the sequential circuits. Here it is diagram of sequential circuit. Basically, sequential circuit is a combination of combinational circuit and memory. Memory gives the previous or past values to the circuit as input and output depends on current input as well as past input values in the sequential circuit. Sequential circuit are of two types. First is synchronous sequential circuit and second one is asynchronous sequential circuit. In synchronous sequential circuit, output changes only at some discrete instance of time, and to achieve the synchronization in the circuit we have to use some timing signals, and that is known as clock. Means clock gives the synchronization in the circuit, while in asynchronous sequential circuit output can change at any time. There is no need of any timing signal. Means it is clockless. There is no need of clock in the asynchronous sequential circuit. Now we are going to talk about the comparison between combinational and sequential circuit. In combinational circuit, output is determined by present input of its input only. And in sequential circuit, output is determined by present values of input as well as past values of output. Means the present input as well as the past values of the output in sequential circuit. In combination circuit, because output depends on only input, it has no memory element and no feedback path. While in sequential circuit, it depends on input as well as past output. It has some memory element and feedback path from output to input. Operations in both the combinational circuit and sequential circuit are defined by the truth table. And in combinational circuit there is no clock signal, while in sequential circuit it may or may have clock signals because it is of two types, that is synchronous and asynchronous. So it may or may not have clock signals. Circuit is simple or simpler than sequential circuit. While in sequential circuit, the circuit is somewhat complex as compared to combinational circuit. In or simpler than sequential circuit. While in sequential circuit, the circuit is somewhat complex as compared to combinational circuit. Operations in both the combinational circuit and sequential circuit are defined by the truth table. And in combinational circuit there is no clock signal, while in sequential circuit it may or may have clock signals, because it is of two types, that is synchronous and asynchronous. So it may or may not have clock signals. Circuit is simple or simpler than sequential circuit. While in sequential circuit, the circuit is somewhat complex as compared to combinational circuit. In combinational circuit, it is built using basic gates like NOT, AND, OR, NAND, NOR, XNOR gates, etc. While in sequential circuit, it is built by using some basic gates as well as combinational logic circuits. Combinational circuits example are adder, subtractor, mux, demux, decoder, comparator, encoder. And in sequential circuit, examples are flip-flops, counters and registers. These are the examples of sequential circuits. Now, we have topic and we have example of sequential circuit, that is flip-flop. Now, what is flip-flop? Basically, flip-flop is 1-bit storage area. 1-bit storage area means it is used to store binary data. Binary data either 0 and 1. 1-bit storage area, 1 bit means either 0 or 1. Now, flip-flop is an electronic circuit with two stable states. What are the two stable states? That is 0 and 1. That can be used to store binary data. The stored data can be changed by applying varying inputs. See, this is flip-flop. In the flip-flop, there are number of inputs. But when we talk about the output, only two output are there. That is like Q and Q complement. Two output means 0, 1 or 1 or 0. Flip-flop are fundamental building blocks of digital electronic system, which are used in computer communication and many other types of system. And flip-flop are used as storage element. It is the basic storage element in the sequential logic, as it store 1-bit data. Now, different types of flip-flops are there. That is SR flip-flop, JK flip-flop, master slave flip-flop, D flip-flop, T flip-flop. We are going to study about today only SR flip-flop. What is SR flip-flop? SR flip-flop is known as set and reset flip-flop. Now, set reset flip-flop, it is implemented by two NAND gates, first NAND gate and second NAND gate. Now, what is the truth table of NAND gate? When we give two input, that is X and Y, in the NAND gate, in a simple NAND gate, then what is the output of that NAND gate? X and Y are the inputs. When we give values, input values 0, 0, then it will give output 1. And when XY values are 0, 1, it will give output again 1, 1, 0, again 1. And when XY input 1, 1, then NAND output is 0. This is the truth table of a single NAND gate. Now, here we are using two NAND gates in the SR flip-flop. Now, S means set and R means reset, and there are two outputs, that is Q and Q complement. When we are talking about two input values, then there are combinations of two input values are 4. 4, that is 0 0 0 1 1 0 and 1 1. We have different combinations of two input values. Now, as our flip-flop Q and Q complement. Q and Q complement have some values, some previous values, and we have to find out the values of the next state or next clock pulse. So we assume the Q and Q complement values according to the input of S and R input values. When S and R have values 0 and 1, 0 and 1, this one, 0 and 1, and we assume the value of Q is 1, then Q complement, value of the Q complement is 0. What will be the next state of the Q and Q complement? See here, when we give input to S0 and R1 and we have previous value of Q is 1 and Q complement is 0. 1 is treated as input to this NAND gate and Q complement, the output, that is Q complement, is treated as input to this NAND gate. Now, when we talked about first NAND gate, S complement value is 0 and here the other input value is 0, 0, 0, 0, 0, the output of the NAND gate is 1. So, we have in the next clock pulse, the Q value is 1. And in the second NAND gate, the value of our complement is 1 and here the second input value is 1. So 1 1, 1 1 gives the value 0. So 1 1 gives the next clock pulse value is 0. So when we get the next clock pulse value 1 and 0, it is same as the previous values, that is 1 and 0 and here is 1 and 0. So it is called as set values. There is no need of change of values. Now second, before going to second part, now earlier we discussed about the SR values, that is 0 and 1. In this case, we take the values Q and Q complement as 1 and 0. When we talked about the second case, we assume the value of Q is 0. Then see here, in the 0 1 case, when we talk about the value of Q is 0 and Q complement is 1, again in the next state we get the values, that is 1 and 0, that is set state. In the next SR values, that is when we talk about S value 1 and R value 1 and we assume the value of Q is 1 and Q complement is 0, this one case, that is 1 1. When we talk about 1 1 as an input to this flip-flop, this one is treated as input to the second NAND gate and this Q complement is treated as input as first NAND gate. We get the values 1 1, that is here it is S value is 1 and input is 0. So 1 0 gives output. What is the output? 1 0, 1 0, 1 0, that is 1. So we get the next value of q is 1, and when we give the value of q1 to the r second AND gate, we get the value 0, that is 1 and 1 0, so 0. So we get values 1 and 0. Now in the next state we assume the value of q is 0 and the value of q complement is 1. In this case, this 0 value is given to this as input 1 and 0. 1 and 0 gives output as 1, and this 1 gives to input first NAND gate 1 1. 1 1 gives 0, that is 0. Again next state is again 1 0. This one 1 0 hold, right? Now in the next one, when we talk about the input as 1 0, 1 and 0, and in this case 0 q value is 0 and here q complement is 1. Now this 1 is given to this and this 0 is given to this second AND gate. 1 1 gives 0 and 0 0 gives 1, 0 and 1. Here is the 0 and 1. And when we take the values, previous value of q and q complement as 1 and 0, it will give again value that is 0 and 1. See here 0 and 1. So it gives the reset state that is 0, right? Now next one, when S and R have values 0 and 0 and Q have value 1 and Q complement have 1 0, sorry, Q have value 1. Now when this value 1 is given to this second NAND gate as 1, then 1 and 0, 1 and 0, 0 1 gives value 1, so 1. This one, here the value of q is 1 and q complement is 1. It will never occur. Both are complement to each other. If the value of q is 1, then the q complement should have value 0. It means when we give the input values to S and R 0 0, it will not perform the operation. It means it will give 1 1, which is never allowed in this SR flip flop. So not allowed. Now this is the truth table of SR flip flop, in which S and R have different input values, that is 0 0 0 1 1 0 and 1 1, and we assume the previous state, that is Q and Q complement, as 0 and 1, 1 and 0 in every combination of input to S and R, and it will give the final state q n plus 1 and q complement n plus 1, means next state, next timing clock pulse. So when S and R is 0 0, then there will be no change. When the value of S and R is 0 1, then it will give the reset values, that is 0 in every case. And when the input is S and R have 1 0, then it will give the set state, that is 1 and 0. And when the input of S and R is 1 1, then it will not allowed for the SR flip flop as it gives the final state as 1 1, which is not allowed. Okay. Now this is the complete SR flip flop. It is the circuit of the SR flip flop, S and R NAND gate, which will give the S complement and R complement, and again it is the latch, SR latch, and it is the truth table of the SR flip flop. SR flip flop is sensitive to input changes only when C is 1. C is 1 means this C is clock. When we give the clock pulse to 1, only then SR flip flop will work. Otherwise, no flip flop can work when clock value is 0. Okay. Thank you.